Hello there guys, welcome back. Another presentation. Today we'll be looking at auxiliary projection. So what is an auxiliary projection? An auxiliary view is a projection on an auxiliary plane that is parallel to an inclined, slanting surface. It is a view looking directly at the inclined surface in a direction perpendicular to it. Auxiliary projections are important for describing the true geometric shapes of inclined surfaces. So now that we got that out of the way, let's just look at an auxiliary demonstration that I prepared, and we're going to try to break this down so that we can understand how this was created. So the first thing here we see is our front elevation and then our plan. So this joint has been created in third angle projection because the plan is at the bottom. There's an X and Y line separating the two joints, and then there's an X and Y prime line which the auxiliary has been casted onto in this area here. This is the front elevation, this is the plan, and this is the auxiliary view. Let's look at this in terms of how will we create this auxiliary view, because the auxiliary view is the final outcome of this joint. So the first thing that we need to do is let's turn on the construction layers and have a look at this. Wow, lots of construction layers. But one thing you see is that there is most of the construction layers that were used come from the front elevation drawing, if you notice that, and then they go down to the auxiliary. So that is the common trend. They go in this direction, and this is what they mean by creating a perpendicular angle here. So the angle right in between here is 90 degrees. That's the perpendicular angle that was mentioned. And I'm going to turn off this these construction layers, because they're kind of confusing at this moment if you don't understand what you're looking at. So firstly, let's break this down. One of these joints I like to consider to be a mother joint, and the other joint a father joint. So in this instance, the mother joint would be this front elevation here. I'll just put a note here, call that mother joint. Why do I call that the mother joint? Because that joint is the joint that is connected to the auxiliary projection. It actually has literal construction cords, creating a physical connection to the auxiliary projection. So I call that the mother joint, and this joint below here, I call this the father joint. Let me just put a father joint. So what happens at the father joint? The father joint, we actually measure. We measure all of these points and relate them back to the X and Y line. So at this joint, we take points from the X and Y line here, and we measure them. So you get a bunch of lines here, just measuring points all around the circle. So the X and Y line is seen as a zero line, the starting line, and these are the furthest points away, and we measure all these points around the circle like that. And then what we do then with this information, we then transfer it over to this point here, which is our X and Y prime, and then we just create these points here by finding them back. So it's a similar, it's an interesting process where firstly you have to identify what is your mother joint and what is your father joint. So on this one, the front elevation is your mother joint and the plan is the father joint. Firstly, we create the two elevations. We set up an X and Y prime line. This line here, so is set up at 45 degrees. 45 degrees is the 9 degrees. Oops. Yeah, that's the 45-degree line here, and we transfer all the information from the X and Y line over to the X and Y prime line. So that's one thing. That's the purpose of this line. This line here, information is transferred over to this X and Y prime line. And this is Zakai. Just look at his work here quickly before we go any further. And he has stripped down his process into 1, 2, 3, 4, approximately 4 steps. 4 steps, yes. The first step here, he has identified the mother join, and he has created his X and Y prime line, and he has decided what he would do is just show the process of projecting lines through the X and Y prime line. So this is just setting up the construction. So he's projecting lines from the mother shape over through the X and Y prime line. That's literally all that first join is about, and it just tells you. On this second join, he has decided to figure out how the circle would look over here. So what he's done is he's created measurements using a yellow layer, and I'm just going to identify that. These are all over here, the measurements for each point around the circle, like I explained. And then he just takes this information, and then he comes back here and he just finds back these points based off of the construction lines that he had, which were sent from the mother drawing. So literally, this is what we'll be doing today. What else did he do? Why did he need to go through 4 steps? Simply because, let's clear off this drawing and let's move over to the next drawing now. Simply because the circle was repeated twice, and so there's a smaller circle here. He did a similar process for the smaller circle, using a green line this time to identify the inner circle. So this circle that we have here on the inside is a smaller radius to this circle here. So that's why he had to repeat this process again for this smaller circle. And then he goes over here to find the square hole that has been created. So this is the square piece here on the plan. 1, 2, 3, 4 square, and then this is it here, represented in an auxiliary projection. And finally, this is everything put together here. So let's just turn off his construction layers, and we can look at this here. Thank you. And dimension 2 and hidden, and that is how the final auxiliary will look when everything has been brought together. So that is one strategy that you can employ. You can break the drawing down into various steps, and then at the end just combine them. Okay, so now let us move on to what we are going to be doing today. So this is the question here that I'll be attempting to solve. Question 3. What does it say? The figure below shows the elevation and plan of a hexagonal truncated prism. Draw full size the given elevation and plan, and an auxiliary view in the direction of arrow is. So the first thing we need to do is we need to reproduce what is given to us. And this has been presented in third angle projection. How do I know this? The plan is at the bottom. So I'm going to come over here and just minimize the screen. But before I do that, I want to show you guys how this will look in a 3 dimension. So this is our shape here, the hexagonal prism. That's how it will look. This is when you look at it from the side elevation. As you can see, it will look something like that. And when you look at it from the plan, it just looks like a hexagon with a hole in the middle. Alright, and this is how it will look in 3D. If we were to look through the object in an X-ray format, you will see the hole there in the middle that penetrates the solid. Okay, enough of that. Now let us start drawing. So first thing, I'm going to go over to my construction layers. I'm on my construction layer. I'm going to turn on my ortho. To turn that on, you can just press your F8 button on your keyboard, or you can come down here and select ortho mode. Okay, good. Alpha line, and I create a line, and I create that line. So I create my T, and what I'm going to do is I'm going to offset 10 above and 10 below. Okay, cool. Now I need to create a hexagon that is 80 millimeters diameter. Okay, no problem. So what do I going to do? I'm going to come here to my shape, and then I'm going to select polygon. Hexagon is part of the polygon family. It asks me enter number of sides. I want 6 sides, so I'm going to type 6, enter. I'm just going to specify a point, enter an option, inscribe or circumscribe. I'm going to go inscribe, so I'm going to go inscribe, and all I need to do then is insert the diameter, the radius of my hexagon, which is going to be 40 millimeters because the diameter is 80 millimeters. Let's just prove this back by putting the dimension over there to there, and that dimension is 80. So that is correct. Let me move this shape now. I'm going to move this shape and just stick it right here. Okay, so that shape looks good there. And what I'm going to do is I'm going to create the circle, and the circle is going to be telling us diameter 40, which means radius 20 millimeters. So that is in. And what am I going to do now? I'm going to project my lines up from these points. So before I do that, I should probably label my points. Label my points here. A. Yeah. So all these points will have a different letter. But for right now, I'm just going to copy a bunch of A's. So this is going to be B. This is going to be C. This is going to be D. This is going to be E. And this one is going to be F. Now, I'm going to project these lines up. Okay. Now, the height of this whole thing is 80 millimeters. So I'm going to offset 80 millimeters from this baseline up to there. And there. I want to fill it. Just roughly fill it everything like that. Now what I need to do is put in this slant of 30 degrees. So I'm going to draw a line, alpha line, pull out the line, hit my tab, or you can hit the less than sign and put in 30, and that's how you get your 30 millimeters. So I've installed my 30 millimeters, and now I'm going to trim this so everything looks like the example, sorry, like the question they've given us there on the paper. I hope you guys were able to follow this process at home and this wasn't too hard for you to follow. So that is my shape. Before I go any further, I'm going to outline this by going, this line is going to be in center, or it's a center line. And this is also going to be in center there. So I'm going to match drop that. MA is the shortcut to match drop. So now what do I need to do? I need to put my text in the appropriate layer. So let me just come in close for that. Okay, good. So far, so good. Oh, I need to label X and Y, yeah? So I'm just going to grab C from here. This is going to be my X. Over here is going to be my Y. So again, this is what I like to refer to as the mother shape, and then this is the father shape. So I'm going to Label this front elevation. And guys, the mother and the father shape can change depending on where you are projecting your auxiliary view from. All right, so far so good. I think we can safely say we have done part A, the given elevation and plan. So now moving on to the auxiliary. Let me just place this arrow in here so that we know where we are looking. Let me just mirror this. So I've just created the arrow just for education purposes. Okay, good. So that is the direction that we are going to be looking. I think we can maximize the screen now because we're no longer looking at the question paper. Okay, good. What I'm going to do is just move this title block out of the way. Perfect. That the front elevation is going to be the mother. Again, what happens at the mother? Construction lines come away from the mother elevation or the mother view, and they hit the X and Y prime line at a perpendicular angle, which is 90 degrees. So let's set that up here. The angle needs to be 45. So I'm just going to set up a 45 degree here. And I'm going to offset this line. Why am I offsetting this line? I'm going to offset it about 100. I offset these lines so that we have a back line. So I send all of my lines to my back line so I have enough space to make my drawing. That's why I create a back line. And that's why I offset that line. So I'm going to label this now my X and Y prime. So let me just do that. So down here will be X. And then here will be Y. So this will be X prime. I usually use X apostrophe to get my prime symbol. And this one will be Y apostrophe. Cool. Now let's draw. For this next step, I would advise you to go into your Object Snap menu and make sure that perpendicular is on. And while we're here, just look at the options that I have on in my Object Snap. I have endpoint, midpoint, center, node, quadrant, perpendicular, tangent, and apparent intersection. Those are what I use on a regular basis. So why do we need perpendicular on? Because when I pull the line from any point to the back line, I am looking for my perpendicular symbol to know that that is where the line belongs. So once I have gotten that, I can just copy these points. One that's going to be there, it's going to be there, 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 and there. Okay, so these are the positions. What I'm going to do now is label them up here. Because I didn't do that, I actually forgot. So I'm going to transfer my labels here. So I know this is going to be an F because F is going, the line F is right here. So this is up here is going to be more than likely F prime. Down here is going to be A and E. And up here is going to be A and E prime. This point here is going to be B and D. And here is going to be B and D prime, and here is going to be C and C prime. So let's just change these now before we go any further. So F. So I'm going to keep all the natural numbers at the bottom, and all the slanted ones are going to be primes. So it's going to be F prime. So up here is going to be A, comma, E prime. Or I should just put it A prime, comma, E prime. And down here is just going to be A, comma, E. Up here is going to be B, prime, comma, D prime. And down here is going to be B, comma, D. and over in this corner is going to be C prime, and at this point here is going to just be C. Now all my lines have gone through to reach my back line except a few ones, so I'm going to extend, and I grip all these, and I just extend to make sure everything touches the back line. Cool, good. So I'm going to trim now, because I don't want them to go past the back line. Alright, now let us now start to plot in this outline shape, because we're going to have to plot in the outline first, and then we're going to have to plot the circle second. So let us go about plotting the outline. So we have set up the mother, we have done the job at the mother, which is to create perpendicular lines through the X and Y prime line. Now let us do the job at the father. I'm going to go over to my dimension layer for this, and again the father figure is the plan. What am I doing from here? I'm going to turn off my construction layer so that it wouldn't confuse us, and at this moment I'm going to be getting dimensions here. So A and B are on the same line, so I just need to create dimensions at A. F and C are on the same the same horizontal line, so I just need dimensions at either F or C, but I choose to use F. E and D are on the same horizontal line, but I choose to take my dimensions from point E. So my dimensions are 78, 79.28, 44.64, and 10. So what do I do with these? I'm coming here at my X and Y line, and I'm going to offset those numbers. So first is 10, and I'm offsetting everything from my X and Y prime line. 44, and 79. Okay, I can remove my back line, and I'm going to put these all in my construction layer, which I have turned off. Okay, so they moved to a layer that's off. That's why they just disappeared. Okay, cool. Now it is time to plot this. So I'm going to turn back on my construction layer here, and let us find where A and B is. So we know A and B is going to be coming somewhere on this line, because this is an offset of 10 away from our construction. Actually, let me just, should I do that? I should do this. All to make better educational material. Okay, look at that. I'm going to put the distance here that I use, distances here that I use, so that we all know. So here is the 79 line, the 44, and then the 10. Similarly to over here. So I just transfer these dimensions, these distances over to the X and Y prime line. Now let us find these points. So where is my A and my B? Now I know my A is going to be here, because I found my A from here. I track my A up to this point here, and then send that perpendicular line down there to the X and Y prime line. This is going to be my B. So once you know my A and my B, alright, I'm going to place a point there. A and B. Okay. So put the points in a different layer. So I'm going to put the points in my text layer, and I'm going to start working with my text layer. And at this moment, I'm going to put some letters next to these points, so that always know. I can always identify these points. So A and B are in. Now let us look for F and C. F and C are over here. So I got a point here. That's going to be my point F. Let me just put that there as point F. And this is my point C. So those are in. Now I need to put in point E and point D. So we know point E and point D are going to come on this line. The furthest the furthest distance offset from the X and Y prime line. And let us find the line for E. So E and A share the same line, and D and B share the same line. So good, I have found them, and they are back here, 1 and 2. So let's put a point there. Okay, text box. This is E. This is D. So we have done the first level. Now I'm going to go over to my outline and quickly just connect this shape using a line. So A from A to B, B to C, C to D, D to E, F, back to A. Okay, that looks good. That's completed. I'm going to quickly save. Now I move on to the primes now. So C prime, and the C prime distance is the same as C. That is the beauty about this, because C and C prime are taken from the same line of C. They all come out the C family. So C is prime, this is the C prime line, but the distance to get to C is 44. So I need to be here. So this is where my C is going to be, right here. So I'm going to put a point here. And I'm going to now put it in text and call that C prime. I'm in the wrong there, so let me just transfer these to my text there and then go back working on my text there for this part of the joint. Okay, so I'm looking now for B and D prime. So I know B and D prime are going to be on this line. My B is going to be 10. So my B prime, and then my D prime. Oops. This is D prime, D prime. So I found D prime by tracking it, and now I'm going to be looking for A and E. So this is the A and E line. I know the distance from A is 10, so A is going to be somewhere around here, A prime, and the distance to E is 79. So let's find my A. Okay, so that's where my A would be, right here. Well, my A prime, to be more specific, and E prime. Let's touch back this line. And E prime will be here. So now I'm going to find where F is, F prime. F prime is going to be a distance of 44.64. Okay, so F prime is right here. Yeah, right here at this intersection. Cool. So I think we are now ready to plot this. So let's plot these primes. We move from A prime to B prime to C prime to D prime to E prime to F prime back to A prime, right? Good. That looks good. Can't really see anything interesting from there. Everything is going to look better when I put in the circle. So at this point now, what I'm going to do is I'm going to turn off my construction layers. Yeah, I'm going to turn off my construction layers, and I'm going to be using my hatch layer as my secondary construction layer. Why did I do this? I need to divide this circle into 12 pieces because I need to plot this circle in the auxiliary view. So in order for us to do that, I need to divide the circle on the plan at 12 pieces. So div 12, and that's there. I'm just setting up my points so that I know div 12. Okay, my 12 points are there, and I am going to label them in text 12. I'm going to copy. Okay. Okay, that's that, and that's finished. So now we have all 12 parts of the circle label. We can now transfer these points up to the elevation. So let's start off with 1. I'm going to send a line up, and 2, I'm going to send a line up, 3, up, 4 and 2 will be on the same line, 5 and 1 will be on the same line, 6 and 12 is the center line, so I'm not going to bother to use that because that's already there. 9 and 10 go up, and 9 is a standalone line that goes up. Interesting enough, the 9 shares the same line as AE, and the 3 shares the same line as BD. Now, time to transfer these over now to, okay, let me just offset 100 again to create a back line. Shouldn't have deleted the back line, but they did. Now let me just create my perpendicular points here. Yep, so I've got them, and for this I'll just copy these points. And once I find one, I just copy and paste. In here. Make center line visible and none. Okay, good. So now we have all our projections installed. Yeah. So now you can finally remove this back line. All right. What's the next step? Now we have done the construction lines. Now we need to measure. So I'm going to be measuring these points. So seeing that 12 is a standalone point, I'm going to measure 12 by itself. And I'm going to put the measurements for the circle out here. I'm going to measure 1, and 1 would also be the same measurement for 11, because 1 or 11 are on the same line horizontally, similarly to A and B up here, F and C, E and D. So at this point, 3 also represents where 9 goes. 3 and 9, they go together. That point is already established, so I don't really need to put that in there. 4 is in, which also is for 4 and 8. 5 and 7 are in, and 6 is a standalone number. 6 is in. So let's go back here, and we are going to be offsetting numbers now. So the first thing I'm going to be offsetting is 24. Then 27. And then 44. 54. 61 and 64. Offset 64. Cool. So I'm going to transfer these now over to my hatch there, so that we can see what we're working with. We don't need these dimensions, so I guess I can turn off the dimension layer also. Yeah. So let us look at this thing now and try to put this thing together. So we know first thing that 12 is right here, and 6 and 12 are on the center line. So let's put them in firstly. The first point here we get to is 12, and then the last point on this line would be 6. Now if we use this technique, we put them in using a different layer, using my text layer. So let's look at here, and if I insert these points on right now over my center line, and I start off at 12 at the top, and then I go down to the very bottom and I get 6. So let's move around in a clockwise direction. After 12 we're gonna get 1, and then we're gonna move out slightly and we're gonna get 2, and then we're gonna move. So that's 12, 1. Oh, is there? Yeah, 12, 1. Seems to be a line missing though. Let me make sure. Did I put in my... Oops. I never measured the distance from 2. So what's missing? 34.64. Okay, so I'm gonna offset that now. 34, and that's right here. So I'm gonna transfer that and put that into my hatch layer. Now, as I was saying, let us find this point here. So we can start here at 12, we go 1, but this is 2, and then this would be 3. So let's remove this one here. So 12, 1, 2, 3, and we come back in now. 4, 5, 6, and come out again. 7, go out again. 8, 9 by itself. 10, 11, and then back to 12 out here. At this point, I'm going to go over to my outline layer and use spline, and let us create this circle. So we move through these points. Cool, that's how it looks. So that there is my auxiliary projection. Now what I'm going to do, I'm going to put the label auxiliary down here. That's it. So this is a wrap. I'm going to turn off my hatch there so that we can all look at this. And there are some points that you wouldn't see, like these points back here, you wouldn't see them. So I'm going to put them into my hidden line, and I'm also going to be drawing this back line from C to C prime. That's also going to be a hidden line. It's going to be there, but when you look at the object, you're not going to see that. So this is the auxiliary projection of this hexagonal truncated prism. Let's turn back on our... Okay, so it's all done now, and I'm just ready to put this into these and recap. So today we looked at auxiliary projection. I attempted to answer this question 3, auxiliary projection. I reproduced the figure, reproduced the given views, the elevation and the plan, and I then projected an auxiliary view looking in the arrow scene on the question paper, and this is what it will look like. I also have a model here to show you how this will look like in 3 dimensions if we were to be looking at it like this. I turned on and turned off my X-ray mode. So from up to the time, this is another presentation. More than likely I wouldn't do any more presentations until next year. So from me here up to the time, I want to wish everyone a happy holiday season and a successful 2021. I am out. Thank you guys.